the half model using the lines developed on Alan's CAD software with, as Ian mentioned, just a few bits of further information such as diagrams and photographs. The boat was actually called Shifty, which is a Dufour 40. The client contacted me through the website for the Niagara on the Lake group with a confidential request, which was to be a surprise birthday gift for her partner. And unfortunately, as so sometimes occurs, there was just a short time in which to make this model. After some discussion, we came down to a half model at 1:24 scale, half an inch to the foot. And this is the model, is the ship itself, the boat itself. Yes, your eyes do not confuse you. The S is reversed. It's a Dufour 40, which is designed in 2005. It has an overall length 39'9", a waterline length of 35'3", a beam of 12'10", and a draft of 5.5 feet 5 inches. This photo shows its modern design with a midships semicircular underwater hull, a plumb bow and a short stern overhang, but a beamy 3-to-1 length to beam ratio, which results in a comparatively large interior. Balancing hull shape, sail area, boat weight and keel form, these modern designs using new materials frequently feature a fin keel, often with a cast iron bulb, compared to the traditional full-length ballast keel blended into the hull. Initially, fin keels were deep blades, but the increased draft was a disadvantage for cruising boats in shallower waters. To overcome this, blade lengths were shortened and a heavy cast iron lead bulb was added. The keel cross-section was modified to compensate for the loss of hydrodynamic lift, while the shorter fin gained the additional benefits of reducing the drag-induced wetted area of the keel. Shifty's rudder is a high aspect ratio design, which you'll see a little bit later, which is almost as long as the fin keel, with a subtle scimitar trailing edge shape, being a feature resulting from computer design optimization. The client didn't have a copy of the lines, so I started a search. There are many photos of the Dufour 40 on the internet under sail, but there were no lines plans. Not surprisingly, designers don't publish these, keeping such proprietary information confidential. Only older model lines are available. So I contacted the Dufour dealer in Whitby, Ontario, but they referred me to the same diagrams as in the owner's manual. I also tried to contact the designer builders, Dufour, in La Rochelle, Bordeaux, but I'm still waiting for a reply. This left the possibility of physically measuring and photographing the boat. The photographs that the client supplied were useful to show some detail, but these were not particularly helpful for technical drawing. I confirmed then that the boat was hauled for the winter in the Royal Canadian Yacht Club shipyard on Toronto Island. But with the harbour ice frozen 6 inches thick, the yard closes seasonally after freeze-up, and there was no access. I was therefore left only with the owner's manual, containing the deck and sail diagrams, while the essential body plan was restricted to the maximum beam diagram. This diagram was insufficient for deriving the sections, so I was faced with conventional drafting with pencil and eraser, and even this would require me to guesstimate the waterline shapes. Conscious of the limited time available to complete the model, I considered computer drafting. I have no experience of this, but I knew a wizard, Alan. Alan immediately agreed he could do the job, so I sent him as much information as I had, including the following: the photo of the boat, a composite of the photos that the client had sent me, an isometric drawing of the hull and the online owner's manual. This is the isometric drawing, which is quite distorted, and Alan will refer to this later. Diagrams of the profile, the deck fittings on the deck plan diagram, and the maximum beam diagram showing the transom that Alan will also refer to later. And this is the body and sail plan diagrams from the owner's manual. So here are the photographs which you saw a little earlier. This is the boat taken from the bow, showing the flat sides and the rounded bottom. Here's the transom, which Alan, as I say, will refer to a little bit later. And that's virtually the same as that maximum beam diagram that you saw a little earlier. Here's the keel with its big chunk of cast iron on the bottom. And there is the big lump of iron looking from the forward end. This is the fin rudder, which you see as a straight line right from the leading edge to the bottom. And here's the probably computer design for maximum effect on the trailing edge. You'll see also that that rudder is just hanging on the back, but it also gives rise to another indication of some differences from normal keels. You can see the rudder post coming up through that. That would have been parallel to the leading edge, and as such, it would take that sort of line midway between the H and the I. You may have noticed that there are twin steering wheels on this boat, and hence there would have been some rather intricate, but strong gearing between those steering wheels and the rudder post. So at this stage, Alan had all the information I had, so I'll now hand it over to Alan to talk about his computer design. All yours, Alan.
I prepared the following video and a few short slides to demonstrate how I use the computer and raise images to recreate the plans and then create the station profiles from which printable templates were made. Now, Ray mentioned that the bottom of the hull was rounded, and in some of the photos, it almost looked flat in a few areas. This is DraftSite, my 2D drawing program. This is the drawing I did for Ray of his boat Shifty. I draw at full scale, full size. I draw on layers so I can turn them on and off. I'm going to show you how I import an image and how I trace that image. So first I come down to turn my image layer on. There you can see the image popping on and off there. And I'm going to pick this image layer. Now I'm going to import an image. I go up to Attach, Image. I find my image. I know it's on my desktop. I know it's in Ray's folder, and it's this one here. I hit Open. I'm going to position it later. I'm going to scale it now at a scale of 1 because I don't know what size it is. And the rotation, I can see in the thumbnail that it's vertical up. I want it to be horizontal. So I'm going to type in here -90. Hit enter. Now it wants me to say, if you look at the bottom corner, it says, where do you want it? I'm going to put it right over here where my crosshair is. I picked enter. There's a little dot there. See it? I'm going to zoom in on it. That's my image. It's very small, so I have to increase the size of it. I work on layers. I'm going to go here to dimensions, and I'm going to throw a dimension in so I know how big this boat is. I'm going to put a dimension starting from the stern, going to the bow, pick a spot, come back out, and I can see here that it is 3 1/8 inches long at full size. I went up into tools and I told it I want it to be dual dimensioned. So I have two dimensions here. This one, 1/8 inch, is at Ray's build scale of 1 to 24. This is full size. This is Ray's build scale. Now, This is a 12-meter boat, and we discussed it and decided we were going to use 19 3/4 inches as his model length. So at 1 to 24, it would be 19 3/4 inches long. I divide that by 1/8 and I get a number, 158. I have to increase this image 158 times. I go up to modify, I go to scale, I pick everything. I tell it from maybe in the middle here somewhere, specify a scale factor, 158, enter. Wham, it's bigger. So I zoom out and I can see it's a little bigger than it should be. It should be 1 foot 7 3/4, 19 3/4, but it's a little larger. So I would have to go through this exercise of rescaling it 1 or 2 more times to get it right. Now, if I wanted to trace this thing, I'm going to go to a drawing layer. I'm going to pick this one. It's green, object layer. And I'm going to use a polyline as opposed to a straight line or a curved line or an arc or whatever. I'm going to use a polyline. A polyline is a series of lines that are joined by, I'm going to call it an elbow joint. I'm going to turn ortho off. Ortho forces me to draw vertical or horizontal lines. I want to be able to draw them at any angle. So I turn to ortho off. Now I'm going to pick a spot here. I'm tracing this now. I'm going to pick a spot here, pick a spot there. Everywhere I pick a spot, there's an elbow joint. These are all straight lines. This is not a nice smooth curved line. These are straight lines. Now I'm going to do something. I'm going to come up here and I come back down just to show you something. There, that's more than enough, right? Now, hopefully you can see that in there. What I'm going to do, I'm going to turn that image off so you can see it better. Image off. There's my polyline. Now, escape. What I wanted to show you is if I pick that line, those little blue squares are the elbow joints. I can grab one of those, hold my mouse button down, drag it down to where I want it, release, pick a spot, and there it is. Now it's not quite right. I'm going to raise, well, maybe it's the other one that's not quite right. I can adjust this one. Now, that's enough adjusting there. I want to show you how I turn, that one's really awful. Anyway, I'm going to show you how I turn this into a nice smooth line. I come down here, I type in P-edit, polyline edit, pick a polyline, this one. What do I want to do with it? I want to spline it. I type down here S. Watch this line as I hit S. Ready? 1, 2, 3, go. It just went nice and smooth. All the corners are gone. But if I pick that line again, all those dots are still in there. I can still grab one of those and move it wherever I want. Now, the other thing I can do with that, once I trace half of it, I can mirror the other half. Modify, oops, get out of there. Modify, mirror, pick this line. I'm going to turn ortho on just so you can see what happens. I'm going to pick the end of that line. See how it wants to copy it? Now it says, do you want to delete the original one? I'm going to say no. Hit enter. Now I got two halves traced. So now I'm going to show you how I make the station line profiles to create the templates. So I've added a few labels here. The top diagram here is labeled shear plan. The bottom diagram here is labeled half a breadth plan. And the right hand side is labeled the body plan. I've got an outline here of station line 9 profile. There's the number 9, here's station 9 here, and all the way down through. First, before I explain to you how it's done, we need to understand what the lines mean. So in the top, in the shear plan, we've got a bunch of grid lines. Those going vertical from 0 to 12 are the station lines marked off in meters. So 0 is the stern, the extreme stern. 12 is the extreme stem or bow. In between are meters, 0, 1, 2, 3, 4, up to 12 meters. The horizontal lines are the water lines cut through the hull, starting at the extreme bottom of the hull, which is marked as 0 here on the left, going up to 1 and 2, and then there's a grid line, horizontal line just above that would be 2.2 meters. So you'll notice the lowest point of the hull is at about station 5, which I've copied the number 5 down here to make it easier to see. In the half-breadth plan, we have the same horizontal lines cutting through, marked off similarly from 0 to 2 meters, but this would be looking down on the plan or looking up, depending on whether you're North American or British. And it's outlining the width of the vessel. This is the height of the vessel. This down here is the width of the vessel. So if I were to take a slice on a waterline here in the shear plan, and it cuts through all of these lines, what I'm going to get is a profile like I see down here on the bottom in the half-breadth plan. So these are the water lines projected or copied to show us what kind of slice we get through the vessel at different heights or water lines of the vessel. If I have all these water lines down here in the half-breadth, and I take a slice through these water lines down here, I copy that profile up in the shear plan, and I get buttock lines. So each one of these lines up here are a slice from down there. Now, I can project the information from both of these views into the body plan to get a profile. First of all, you need to understand that these I created by getting the dimensions off of the isometric plan that Ray provided me, where the views were a little bit offset. You probably remember seeing those, and you'll probably see them again. So I did not draw these from anything other than those plans and looking at the dimensions where the lines were. So they're as close as I could approximate by looking at that plan. Same with down here. I copied or created these by copying them to positions that I saw on those plans. Now, to project the information from these over to the body plan, I'm going to show you how I do it for station 9. Right here, station 9. So first I take the center line from the half-breadth and I extend it across so it intersects with the center line of the body plan, which you see right here. Then I draw a line 45 degrees up and away. Now, if I'm drawing on the right side of the body plan, I'm drawing from the widest point of the hull forward. Those profiles on the right side are from the widest point forward. Now, I mentioned earlier that the lowest point was station 5, but the widest point is at about station 4. So from 4 to 12 would be drawn on the right side of the body plan. From 4 aft to 0 would be drawn on the left side of the plan. To draw on the left side, I'd have to take this 45-degree line down here and draw it up and out to the left. Now, I'm going to draw 9, which is forward of the widest point, on the right side. So now that I've got my center lines intersected and this 45-degree line here, I go down to station 9, and I see where the widest point is, right there, and I draw a line across. Whoops, wrong way. Sorry about that. Let me back out here. So I draw a line across till it hits this 45-degree line here. And then I extend it upwards. Now, likewise, I go to station 9 up here at the highest point, and I draw a line across. Where those two lines, this one coming up and that one going across, intersect, that should be the uppermost point at the outermost part of the vessel. Now, if I draw a line across from the lowest point of the shear plan, which would be the bottom of the hull at station 9, and I project it across, and I do likewise from the lowest point, which of the half breadth, which would be this water line here, and I draw that across, where they intersect should be the lowest point of this hull, which is somewhat flat. We can see that on the photographs and whatnot, that the bottom of this vessel is somewhat flat. So now I can come over here and I can look. You can see right, let me get rid of that line. I'm just going to delete that, and I'm going to delete this. So now you can see I drew a straight line across to where those lines intersected. And I drew a straight line from here down to where this line intersects with another level. I can project that across exactly the same way. And I draw this line down. I know that this profile is straight, diagonally straight here, because I can see that on some of the drawings and on the photographs that it's straight. It's not bowed or anything. It's a straight hull. And then it curves to join here. And that's what I did. I just drew it in. Now, as I draw the other profiles in, I know that they're supposed to blend. And because these two views here are my best measurements off of those isometric drawings, they don't always look correct. They're not where they should be because those are approximations. They're by eye. They're at least a second generation, and what I copied from might have been stretched a little bit. I don't know. So I can use some artistic license to manipulate my lines to make them look as I believe they should from the photographs. If I had the naval architect's drawings, I could do that with a little more accuracy, as accurate as his drawings are. If he did them in CAD, which is computer-aided drafting, which is this what you're looking at here, this program, then he should be pretty darn accurate. If he did them with pencil on paper, well, you're as accurate as the thickness of a pencil lead and the, I'm going to call it ruler, but really we call them scales, the scale that you're working with by eye. So some artistic license is allowed to blend these profiles to make them proper. Now, okay, now I'm going to show you how I recreate the top of the deck and the deck camber for station 9. So that would be here, station 9, and you see on the left. The green line right there represents the top of the hull on the outboard side. The yellow line represents the top of the deck on center. I need to get this point over here. To do that, I'm going to draw a line. So pick a line, go from the top of the deck at the highest point and draw a horizontal line across. Where it crosses that center line is the top part, the topmost part of the deck. This is the topmost part of the hull. So I need the other side of the hull over here to be able to draw a 3-point arc. So I'm going to mirror, and I showed you how I did this before, mirror that part of the hull over to the other side. And there it is. Now I'm going to pick to draw a 3-point arc from the top of the hull on this side to where it intersects at the center line, the top of the deck there, back down to the top of the hull there. And it's done. I get rid of this line. Easier said than done sometimes. There, delete. And now you can see it. That's the deck with its camber. And that's how it's done. And that's it. Okay, so this slide is the isometric that the drawings were recreated from. You can see that the views don't align. The one in the middle doesn't line up with the one on the far right, and the one on the bottom doesn't really seem to line up with the one above it. In reality, being an isometric, they do somewhat align, but it screws with your eyes trying to visualize that. And all I did was, you can see he's got the grid lines off on the far left, and he's got the grid lines down below. And I simply counted where each of the water lines or the other lines crossed and recreated that on my drawing as best as I could. And then once I had that traced, then I manipulated the lines a little bit to make them look more like this isometric. Made them blend and match each other a little bit better. And that's pretty well how I did that. So this was the recreated drawing I made of the three views at 1 to 24 scale. This is with the individual sectional views at each station completed, as you can see in the top right there. All the profiles are cut in, and they then were copied out to make the templates, which Ray is going to talk about.
Okay, so Alan sent these lines to me, but when I printed them, I immediately noticed a problem. The dimensions on the sections did not coincide with those on the deck and the profile plans. After looking at these, Alan came back to me with the answer, and that was that the paper was slipping as it passed through my newly acquired printer. He suggested I take the individual section drawings to a commercial printer, and bingo, problem solved. Lessons learned, and my new printer returned, and a new printer was gained. And so I set to work. These individual pages here were done on 8x10s, and you can see the individual sections that Alan produced. This is section number 7, with the full size measurements, 10 feet, 8 and 15/16, and 5 3/8 being the 1 to 24, ½ inch to the foot size that I would use. This is section 7, this is section 10, and this is section 1, I think, right at the transom. So I took those, traced the sections onto 40 thou styrene sheet that I had. Many modelers use cardboard for this, but I find that when making half models, these get rather bashed around a bit. And so I happen to have a stock of 40 thou styrene sheet, which is very useful to me. So I was able to cut these out, showing the lines that I would need to use. This is section 1, station 3, and hence I was then able to get all the lines for each of the templates on the body. There's some of the templates. There's the waterlines plan, and here's the profile. So I then took my stock of quite old basswood sheets, passed them for my planer to give me good, accurate ½ inch thick planks, and traced the sections onto those basswood sheets. Here's a typical basswood lift that you can see with the station lines in. These three black dots are in fact 3/4 inch holes that I bore in order to produce registration spots for these dowels that I use. The dowels allow me to separate each of these lifts and makes it easier for actually producing the larger shapes as I go through. You can see from these lifts over here that the longest lift is this one here, which is at the outer edge of the transom. And then at this point here, this lift is traced onto the underside of the lift here to show how you've got to carve this lift right down onto that flatter bottom. The plumb bow is shown by the fact that we have virtually the same line all along here. And at that stage, that's where the plumb bow comes back in. Here's the lifts assembled. Station lines are lined up and the three dowels are set into the holes. These dowels allow registration of the lifts after I separate them to make it easier for initial shaping. Here's the hull after the lifts are glued and pegged. Another advantage of the dowels, which prevent the tendency for the lifts to slip against each other while I'm clamping them. The upper extensions of the dowels hold the hull firmly in the workmate for final sanding to shape. I should also add that when restoring old half models, I occasionally find that the lifts have delaminated. Not much, but enough to crack the paint. So I believe the dowels would help to prevent this. Here's the shaped hull with the station lines in and with the dowels in position. This is the keel with the bulb attached to it. You can see it has been given a hydrodynamic profile. And here are the hull components still with the dowels pegged at the top. Eventually, of course, I will saw these off for the deck to get the deck camber. This shows the back of the hull with the keel and the rudder located and secured into their mortises. Experience has taught me that fin keels are easy to knock and dislodge while working on a hull of this type. So I use pegs to add to the glue to secure them to the hull. I use wood filler for fillets at the keel junction with the hull, and there are the pencil lines of the stations retained. Here's the hull faired and sealed. And for those who are interested, this is the sanding sealer that I use. I find it as I can use 3 coats of it, sanding between each, and that's sufficient on basswood hulls. The last sanding is used with 600 grit paper. This photograph shows the hull at a later stage. It's out of sequence, but it does show where I located these screws for eventually mounting the hull onto the backboard. You can see I've got a measurement of 1 3/8 inch there and 1 3/8 of an inch there. And it's 16 inches between the two. That's a standard sort of length for wall studs in Canada. So if anybody wanted to fix it to a wall, that's where you would put them. It also shows the danger of primer overspray. What I do when I'm painting these is I put the model, I lie it on a block of perhaps 1/2 inch thick spare wood and then spray. But it does show how overspray can get everywhere, even under a 1/2 inch thick block underneath. Here's the primed hull, all finished, all the bumps and nicks smoothed out, with the fin keel in place and the rudder. Now here is the primed hull set on my waterline setting jig. The jig is a simple 90-degree setting with these triangular fittings at the ends, making sure it's a true 90 degrees. There are 2 slots, 2 vertical slots in the back of this board, round about here and here, where I can put screws in to locate this hull so that the water lines, which can be fixed at that point and at the stern, can be lined up with a convenient parallel line along the back. There's the parallel lines associated with just one water line at that point. Here's my homemade engineer's height gauge, which I find I developed it better rather than just a block of wood with a pencil stuck to the top of it. And so here's the water lines being traced in. This one on the right-hand side is always a tricky one as it comes underneath the transom, underneath the counter here, because the force, while it's not large, it does tend to force the pencil to droop a little, which is really the reason why I developed that homemade chunk of aluminum you saw a little bit earlier on. So after the first coat of white hull paint, I checked the water line and the name locations on the hull. And here is a paint specification card for the boat that the client sent me. It shows the color, which is called 3M for the stripes and the boat name, with the reversed S at this point. This is a smaller font size using RCYC for Toronto with a slightly different pair of blocks. And there are other paint colors put on this, which I didn't need to use. Here's where I'm putting on the masking for the boot stripes. The stripe is 1 millimeter wide. That's the 1/16 of an inch yellow tape. And I've put white masking tape on either side of that so that I could get a good spacing on it. This is the boot stripe tape being removed so that I could then mask the rest of the hull and paint this line in here. And here's the rest of the hull masked for the boot stripes. And here we show the anti-fouling paint color, the boot stripes, the tow rail, the cove stripe up at the top here, and the narrow rectangular slit ports of late Dufour designs. You should note that the anti-fouling paint, when it's freshly applied, changes color as it oxidizes and slowly ablates in the water to an indeterminate but variable gray shown later in the photographs. Here's the detail of the tow rail and the port slits. The tow rail, I fixed that by slightly roughening up the paint, the gloss paint on the top of the hull there. Use white glue because it's the easiest to manage rather than epoxy. Fix on the tow rail and then use trunnels, which you can see there and all along the rest of the hull to ensure that that tow rail stays in place. Here's the painting complete with its name reversed, the S reversed, shifty, and all of the necessary colors. During the painting of this, I checked in a conversation with the client, who told me, in fact, that they had a bit of an argument with a marker boy during a race, and the three boot stripes had all been painted to the same color, which is why it's slightly different color on the original painting. So that was good. I only needed to use the one color for the three stripes. This shows the model, again, with those three stripes that you can see there, each of a slightly different color. But the client wanted them all of the same color because that's what it is at the present time. You can see on this photo of the full-size boat, that's an S drive, where the engine is mounted inside the hull, and then there's two 90-degree bearings, one taking it down and the other one hanging at the back there, 90 degrees. It's an S drive. This shows the model on its teak backboard, and here's the model with its nameplate. The nameplate, in fact, is a piece of aluminum, which my supplier then has. It is a multi-layered piece of aluminum with a black layer, which she then laser prints with detail of the hull at that point. This is not the actual backboard that I used for Shifty. I forgot to take a photograph of it, but it's typical of the sort of backboard that I use. It's 5/8 of an inch thick, good one side teak ply. There's no point in having good two sides because the back side is never shown, of course, and is very expensive. So I only need good one side teak ply. The edging is in 3/4 by 3/8 teak, solid teak. And these are the hangers that I use for the back. They're available at Lee Valley. They're available in two sizes, 20 millimeter and 25 millimeter. And this is a bumper foot, which prevents the backboard leaning forward when it's hanging on the wall. Here's the detail of the nameplate, and there's the stripes, the ports, and the tow rail. There's Shifty complete, and lastly, a group of photographs showing the model, the finished the big boat, and the 3 lines plans that we were talking earlier with Alan. And so Alan successfully derived the lines plans on the computer software from the limited information available to him, ensuring greater accuracy than I would have been able to achieve using pencil and eraser, and saving me considerable time in doing so. With that foundation, I was able to produce the model, finished on time, for a very happy client. And yes, I could have guessed at the whole shape for a model, and only I would know, but half models by their nature should be at the best standards of accuracy. Who knows if the model would be of such academic interest in future, but I am happy that it is as close as possible to the lines of the real thing.